So how do we simplify? The whole idea is to be able to take a polynomial, break it up into its factors, and find the zeros really easily. So one thing you did back in Algebra 1 or in Algebra 2 is you learned how to do this polynomial long division. And what we want to do is we want to divide this polynomial, that's the dividend, divided by the divisor to get a quotient and see if the remainder is 0, and that'll tell me it is a factor. So what we do is we ask ourselves, and this is long division, what times x is x cubed? Well, that's x squared. So then what I'm doing in my head is I'm taking x squared and multiplying it by x minus 1. That gives me x cubed minus 1x squared. And then just like with long division, you got to change your signs, you got to subtract them. That leaves me, if the x cubes are gone, which was the point, and we got negative 2x squared minus 6x plus 8. Then you ask yourself, what times x squared, or what times x is negative 2x squared? Well, negative 2x. So I'm multiplying in my head, I'm multiplying negative 2x times x minus 1. So that's going to be negative 2x squared plus 2x. But then again, we've got to change our signs, subtract them. So that's going to, the 2x squareds are gone. That leaves me negative, let's see, what is that? Going to be negative 8x plus 8. And then I ask myself, what times x is negative 8x? Well, that'll be negative 8. And I'm going to multiply that times negative 8, gives me negative 8x plus 8, and then again change the sign, and that gives me 0. So because there's 0 remainder, that tells me that x cubed minus 3x squared minus 6x plus 8, so let me rephrase that x minus 1 is a factor of that polynomial. And this is what the remainder is. So at this point, I could say x minus 1 times this is that partially factored. Now, this polynomial long division is long. It's kind of painful to do. We learned, or if you haven't learned about it yet, we're going to learn about synthetic division. So I shrunk all that work up off to the side. So synthetic division does this. You ask yourself, what are you dividing by? Hey, I'm dividing by x minus 1. Well, where is that equal to 0? So I add 1 to both sides. I get x equals 1. So then you start off, it looks something like an upside down division key, or division bar. I'm going to put the 1 there, and then you pull the coefficients off of each of these terms. So I've got a 1, I've got a negative 3, I've got a negative 6, I've got a positive 8. Kind of similar but different. I'm going to bring down that 1. I always draw an arrow as a reminder that I don't have to write any number there, and that I'm just bringing this first number down. And then what you do is just multiply. What's 1 times 1? Well, 1. Now I add. Well, negative 3 plus 1 is negative 2. Then I multiply. I'm multiplying negative 2 times 1. I get negative 2, then I add them, I get negative 8, then I multiply, negative 8 times 1 is negative 8, I add them, I get 0. Notice, 0 remainder, and then if I take a look at these numbers here, 1, negative 2, negative 8, you see how that's the same as what we divided as our quotient, 1x squared minus 2x minus 8, and that's how you can read your divisor. It's always 1 power, or your quotient, I mean. That's always 1 power less than you started with. See, I started with an x cubed, and I'm ending up with an x squared. So that's how we get the quotient, and then I can always come back and write a set of factors as x minus 1 from this part. Remember, we changed the sign. So that's long division. I mean, that's synthetic division. So we'll do a couple of these, and then I'll do one more just to walk you through it, and then I want you to try B, try C. Stop the video, try those problems, come back and check. So for A, I'm going to write 2. 2 outside my division bar because I took the x minus 2 and asked myself, when is that equal to 0? Well, when x equals 2. Then I pull the coefficients off of each of those terms. So 1, negative 3, negative 6, and 8. Draw my arrow, bring down the 1. Then I multiply. 1 times 2, I get 2. I add those, I get negative 1. Negative 1 times 2 is negative 2. Add those, I get negative 8. Negative 8 times 2 is negative 16. I add those, I get negative 8 as a remainder, which tells me this polynomial doesn't divide evenly by x minus 2. In other words, x minus 2 is not a factor of that. Now, to get my answers, remember how we had to start with 1 power less than what we started with? So I'm going to write 1x squared minus x minus 8. Then I'm going to write plus a remainder of negative 8 over x minus 2. Doesn't get us very far, but it does help us get a little bit out of this, okay? So why don't you try this next one? In fact, before I stop the tape, I'll prompt you. What number, by looking at this denominator, what number goes here? Look at what I did there. And then you put the coefficients here and then do the division. So stop the video, try it, come back and take a look. Okay, so hopefully you stopped it and tried it by yourself. And so I changed, I said x minus 3, or x plus 3 equals 0, which means x equals negative 3. And I just pulled the coefficients off of each of those terms. I'm going to bring down the 1. Now I'm going to multiply, gives me negative 3. I add those, I get negative 5. I multiply, I get positive 15. I end up subtracting here, and I think that's negative 6. Negative 6 times negative 3 is positive 18. I get a remainder of 0, which is good. That tells me that x plus 3 is a factor of that. So to get the quotient, I'm going to write 1x squared minus 5x minus 6. Alright, so that's the quotient with a remainder of 0 if you want. You could write 0 over x plus 3, or plus. So try this next one. So I'm going to write negative 2 outside because I changed the sign of the denominator. I'm going to write down all the coefficients. I'm going to bring down the 1. I'm going to multiply. I add. I multiply. I subtract here, of course. So what's that? Negative 16. And then positive 32 leaves me a remainder of 2. Not a factor, so 1x squared minus 6x minus 16 with a remainder of 2 divided by x plus 2. Now this one, this D, I'm going to walk you through this one. I'm not having you to try it because there's a little twist to it. Okay, you notice how, well, we can start out with writing positive 4. But then do you notice in this is how there's no x squared term? We got to put a placeholder in there, because you've got to have every power of x represented down to x to the 0, right? That's what the 16 has. So I stuck the 0 in, and that's the part that people make mistakes about. So to make sure you don't make that mistake. So I'm going to bring down 1. I'm going to multiply, get 4. I add. I multiply. I add. I multiply. I get 0. So 1x, so that means x minus 4 is a factor. I get x squared plus 4x plus 4. And if I want, I can write plus 0 over x minus 4. Okay, so why don't you go ahead and try the rest of these questions. And I think what I'm going to do, instead of recording a video for these 3, I'll just write it on my paper and show you my work that way. So now we're getting into the nitty-gritty of this, and we got to factor these polynomials. And this, I don't know who came up with this. Descartes, one of those smart people back a long time ago, found out that if you take your constant term, that last term, divide it by the very first coefficient, you're going to be able to list all the possible rational zeros. In other words, all the possible solutions where we could divide it and get a 0 for remainder, or and where there's no square roots or anything. So for this problem here, I see 8 is my P number, so I'm going to write 8. Actually, I'll walk you through this handout. So the handout says list all the factors of 8. Well, 8 is 1, 2, 4, and 8. And all the factors of 1, well, 1. That's easy. So now we're going to list all the combinations. Well, I could list 1 over 1. I could list 2 over 2. I could list 4 over 4, or 4 over 1, I mean, and 8 over 1. So that's all the possible combinations, because these are all over 1. Pretty easy. And then we're going to try some. Now we're going to guess and check. There's 8 different synthetic divisions we have to do. Hopefully we don't have to do them all. So there's suggestion that we try 1 as a factor. So I'm going to write 1. I'm going to pull the coefficients off this. So 1, -5, 2, and 8. Bring down the 1. We're going to multiply. That gives me 1. Gives me -4. I'm going to multiply. -4. That gives me -2. That gives me -2, which is a remainder of 6, not a 0. So that tells me 1, or x minus 1, is not a factor, or 1 is not a solution to this polynomial. Now they're telling me try -1. Okay? Well, that's something I didn't do about the plus or minus. Each of these could be plus or minus. So 1. Let's see. I'm going to bring down the terms. Let's see. 1, -5, 2, and 8 again. Bring down 1, -1. That gives me -6. That gives me +6, which gives me 8, which is -8, which gives me 0. So, as it tells me that -1 is a factor, so that tells me that I can have, well, I can write it out this way. I can write x minus plus 1, because I changed the sign, remember. And what's the remainder, or the quotient, is x squared minus 6x plus 8. Now, we could do synthetic division again and try one of these other factors on this part, but, you know, that factor is pretty easily to x, what is it, x minus 4 times x minus 2, and that's x plus 1. So there we've done it. We've got the factors of that polynomial with only having to do synthetic division once. Do a couple of these problems that are on page 13. Okay, so I'll do the first 2. I'll do the rest of them on paper, and I'll put those on the website. So here we go. We're going to put this all together. So what are some possible rational roots? Well, I've got -18, so I could do negative plus or minus 1. I could do plus or minus 2. I could do plus or minus 3. I could do plus or minus 6. I could do plus or minus 9. And plus or minus 18. Those are all possible factors of -18. And for 1, I can do plus or minus 1. So I've got all these different choices I can use. Okay, so then to try, what are we going to try? Where do we start? Well, it's just a crapshoot. You just try one that looks like it might work. I see that 18's even. I'm going to try dividing it by 2. And in fact, I'm going to try, I see 18's negative, so I'm going to try doing synthetic division with -2. So I'm going to try -2. I'm going to write down those coefficients. Plus 21. I guess I didn't have to write plus, but I did. I'm going to bring down the 1. Now I multiply, I get -8, -2 I mean, which is -10, which is +20, which is going to go 41. That's no way that's going to work. So I'm going to stop, not do any more work there. So then I'm going to try +2. And so I'm going to do 1, -8, 21 again, and then -18. So then I bring down 1. 1 times 2 is 2. I get -6. -6 times 2 is -12. Let's see. 21 21 minus 12 is 9. 9 times 2 is 18, and I got very lucky. That worked. So that tells me that positive 2 is a root. I know it's rational because it's a whole number. There's no square roots. Or it could be a fraction, it could make it rational also, but there's no square root, so I know it's not irrational. So that tells me my factorization is going to be x plus 2. And then I could keep going with synthetic division. However, since this is just x squared minus 6x plus 9, I see that factors to x minus 3 times x minus 3, or x minus 3 squared. So that's the additional factorization, which tells me I've got one more 0, and that's 3, and it's rational. So that's that. So if you want, you can try this one yourself, and then come back and watch. Notice one caution. Notice this is missing x squared. Okay, so don't know if you tried it. I'm going to go ahead and do this. I see my rational roots are plus or minus 1, plus or minus 2, plus or minus 8. I should have said 4 because it is 4. Let me erase that. 4 times 4 is 16. Plus or minus 8 because 8 times 2, and then plus or minus 16. And then the leading coefficient for the x cubed is 1, plus or minus 1. So what are we going to try? I think I'm going to try 2. And I'm going to do the 1. I'm going to do the 0 for the x squared that I'm missing. I'm going to do negative 12, and then I'm going to do positive 16. I'm going to bring down the 1. 1 times 2 is 2. 2 plus 0 is 2. 2 times 2 is 4. That's minus 8. Oh, did I ever get lucky? 0. So x minus 2. And then that is x squared plus 2x minus 8. Well, that factors to x plus 4, x minus 2. So I'm going to get what for zeros? I'm going to get 2. I'm going to get negative 4. And then I've got another negative 2. So I've only got those 2 zeros. So they're both rational. Do I need to do anything else? I don't think so. So hopefully this is good enough. I've got all my answers online for the rest of these problems. So go ahead and try them.